Hello everyone, this is COMS 300 exam 2 review video. So in this video, I will talk about information about exam 2 and I'll review some concepts and statistics related to exam 2. So first I will talk about information and then I will review things covered in the exam 2. First, exam 2 will be on this Thursday, November the 2nd at 1 p.m. to 2:20 p.m. in Wells Hall in our large lecture room. And the format is the same with the exam 1. So there are 40 multiple choice questions, and students will prepare a pencil, student ID, and a calculator. On the exam, phone calculator is not allowed. So please prepare the calculator. And also you can check the exam 2 study guide with some practice questions on D12. Then I'll review exam 2. So first I will talk about how to summarize the data, like mean, mode, median, variance, and standard deviations. And then I will talk about covariance and correlation. And then I'll go to z-score, probability, distribution, and then I will talk a little bit about regression. And finally, I'll review the levels of measurement. So the exam 1 also covered the levels of measurement, and also in exam 2, some questions will talk about cover levels of measurement. First, I will talk about how to summarize the data. So in summarizing data, we talk about the following concepts and we learn how to calculate those things. So first one is the mode. And mode is the most frequently observed values. The median is the middle value in the ranked order, ranked distribution of the values. The mean is just average. So when you calculate the mean, you will sum the values and divide it by the total number of total number of observations. Also, we learned about variance. And variance is the value that describes how widely dispersed the data are. So if the data are widely dispersed and a lot different from each other, we can say the variance is really high levels of variance. However, if the various data are similar to each other or clustered around certain values, then the variance is low. The levels of variance is low. And also we talk about standard deviation. And also we talk about variance estimate and standard deviation estimate. First, we can review some kinds of variance. So the variance shows how widely dispersed the data are dispersed. So if the data are widely dispersed, we can say the variance is high. If the values are clustered, the variance is low. So then let's think about this example. So there are two groups here, and the blue group and the red group. Which group has high levels of variance? Which group's variance is high? So in the exam, you will provide it with these kinds of like graphs and think about which group has high values or not. So in the blue group, the values are widely dispersed. So starting from 100, 50, 0, 100, 50, 150, even 200 or 220. Areas are widely dispersed. So, however, in the red group, the values are clustered and not that different from each other, like 90, 95, 100, 99. So most of the values are around 100. Then we can say that the blue group has higher levels of variance than the red group because the values are spread widely dispersed. Then the same with the standard deviation. When we calculate the standard deviation for each group, then the blue group has high levels of standard deviation, but the red group shows the low levels of standard deviation. Then how to calculate the variance? So we already practiced it in the recitation. So I just want to show you some formula and the steps to calculate it. So when you calculate the variance, your variance is the sum of square differences between each value and the mean, and then you will divide it by the number of observations. The formula is like this. So sigma indicates that you have to sum the values. So when you calculate the variance, first you have to calculate deviations from each values, which means that you have to calculate xi minus x bar. The x bar is the mean here. So for each value, you have to calculate the difference from each value and the mean, x bar. So this is the deviation. And second, you will square these deviations, which means that you will calculate xi minus x bar squared. Then for each data point, you will sum the square deviations. Then you will divide the squared sum of the square deviations by the number of observations. And so this is the way how to calculate the variance. Then how can we calculate the standard deviation? The standard deviation is square root of the variance. So you can first calculate the variance and take the root, and then you can get the standard deviation. However, when you're asked to calculate the variance estimate or standard deviation estimate, the formula might be a little bit different. So when you asked to calculate the variance estimate, then you will see this kind of formula. So this is basically divide the sum squared differences by the number of observations minus 1. But this part is same with the variance. So for each data point, you calculate the differences between each data point and the mean, squared it, and summed it. Then you will divide it by the n minus 1. That is the number of observations minus 1. So this is the way to calculate the variance estimate. And also in the exam, if you are asked to calculate the standard deviation estimate, you will take the root of the variance estimate. So this is the variance estimate part. And then after calculating the variance estimate, you will take the root, and that's the standard deviation estimate. So in this way, in the exam, you will ask to calculate the mean, variance, standard deviation, variance estimate, standard deviation estimate. Next, I will go to the covariance and correlation. So first, I will talk about covariance. The covariance is a measure of the joint variability of two variables. So how changes in one variable is related to changes in other variable. So when you review covariance, you have to think about how to read the graphs. So you will provide with the graphs like this, and you will think about the covariance between two variables or relationship between x and y. So first, as graphs shown in the left, as one variable increases and the other variable also increases, like as x increases and y increases, then we can say this is the positive relationship. Then the covariance between x and y is positive values. However, as shown in the middle, when one variable increases but the other variable decreases, which means that as x increases but y decreases, then we can say this is a negative relationship. Then covariance between x and y has a negative values. However, when there is no relationship between x and y, so as shown in the graphs in the right side, as x increases but there's no changes in y variable, like this, then we can say there's no covariance. So covariance value is 0. So in this way, you have to read the graphs and think about how the graphs are related to the covariance values. And also in the exam, you will ask to calculate the covariance and correlation. So we already practiced it in the recitation 2 weeks ago. So I will just show you how to read the formula. So covariance formula is like this. So first, you will calculate this part, calculate xi minus x bar times yi minus y bar, multiply them, and sum it, divide this by the number of observations minus 1. So for step by step, the first, x bar is mean of x, y bar is mean of y. So you have to first calculate the mean of x and mean of y. Then for each data point, for each values of x and y, you will calculate the deviance or differences like you did in the variance. So for xi minus x bar, yi minus x bar, for each cases. Then you will multiply deviations for each cases. So xi minus x bar times yi minus y bar. And you will sum it. So you will sum these multiplied deviations. Then you will divide the sum by the number of observations minus 1. This is the way to calculate the covariance. And also we'll talk about correlation. Covariance and correlation are really similar concept. The correlation is more of a standardization of covariance. So the correlation shows the relationship between two variables such that changes in one is associated with changes in the other. So you can see the graphs and reads the correlation the same way. When as shown in the left side, as x increases and y increases, then we can say this is a positive relationship and correlation values is positive. However, as shown in the middle, as x increases, y decreases, and this is a negative relationship, and covariance and correlation value is negative. However, when there's no relationship between x and y, as x increases, there's no significant differences in y, like graphs shown in the right side, then we can say correlation value is closer to 0. Then we can also think about the strengths of the relationship. So by looking at the correlation, we can see the directions of the relationship, like positive, negative, or no relationship. And at the same time, we can see the strengths of the relationship. Let's look at these two graphs. So both graphs shows the positive relationship because as x values increases, y values also increases. However, if you are asked like which one shows the higher correlations, you can see which one shows are more clustered, or which one is less spreaded. So for example, graphs in the left side, it shows the positive relationship between x and y. However, the data points are really clustered with each other around the lines here. However, in the graphs in the right side, it still shows the positive relationship. So as x increases, y increases, but data points are not clustered and spreaded or dispersed. Then we can say this is a positive relationship, but the strength is a little bit low. So we can say like both graphs shows a positive relationship as x increases, y increases, but the left one shows the higher correlations because they are clustered around the lines here. So in this way, when we see the correlation, we can see the strengths and both the strengths and the direction of the relationship between two variables. And then also in the exam, you will ask to calculate the correlation. The correlation we also practiced in the recitation 2 weeks ago. The correlation formula is like this. So basically, to calculate the correlation, you have to first calculate the covariance. So correlation is covariance and divided by x and xy, which means that you will first calculate the covariance and divide the covariance by the standard deviation of x and standard deviation of y. So if you calculate the covariance first and then divide it by standard deviation x times standard deviation y. That's the way to calculate the correlation. And in the exam, you have to calculate the correlation with the calculator. Then we'll go to the z-score. The z-score shows how far from the mean a data point is. So this score shows that whether my score, how far my score is, how my score is far from the average or the mean. So the z-score is measured in terms of standard deviation. How far my point is, each values are far from the mean in terms of standard deviation. The z-score is calculated in the following way. Z-score equals each values minus mean divided by the standard deviation. It's not that different, right? Yeah. And then first you have to calculate the z-score and think about how to interpret the z-score. So if the z-score shows the positive values, which means that the value is higher than the mean, which means that positive values of the z-score is my value, the data point is above the mean. However, if the value is, this score is minus, which means that the value is below the mean. And then what is the meaning of z-score of 0? It means that my value is same with the mean. Then we can say the z-score is value 0. So if the z-score is 0, it indicates that the data point score is identical to the mean score. So suppose that the COM300 exam1 average is 80, and I also got an 80. So my score 80 is same with the average 80, then my z-score is 0 because my score is same with the average of the total students. And also, by looking at the z-score, we can estimate the proportion of cases below or above the z-score. So when you think about the distribution like this, normal distribution, this is really symmetrical. The half of the cases are above the mean, and half of the cases are below the mean because they are symmetrical. So suppose that there are 200 COM300 students, and their average score is 80. Then 100 students, half of them got below the mean. However, half of the students got above the mean. So if the z-score is 0, we can say that approximately half of the cases or 50 of the cases fall below the mean or below the z-score of the 0. So in this way, you can relate the z-score with the proportion of cases below or above the z-score. And how about this? If the z-score is -1, what is that? The z-score of -1 indicates a value that is one standard deviation below the mean. So my exam 2 score is z-score -1, which means that my exam 2 score is one standard deviation below the mean. However, my z-score is 1.0, positive value, which means that the z-score of 1.0 indicates a value that is one standard deviation above the mean. In this way, we can calculate the z-score and think about how to interpret the result. How far my score, each values are far from the mean. This is what the z-score means. And also we can think about the proportion of cases. So according to some statistics, there are 34% of cases far between z-score of -1 to 0. So in this basis, z-score between -1 to 0, there are 34% of cases. And this is symmetrical. So between z-score of 0 and the 1, there are also 34% of the cases fall. So between -1 to 0, there are 34%. And between 0 and -1, there are also 34% of cases. So in conclusion, approximately 68% of cases fall within one standard deviation of the mean, which means that between z-score of -1 to 1 in the yellow area, there are 68% of cases fall. Then what happens if the z-score is -2 or 2? If the z-score is -2, which means that the value is 2 standard deviation below the mean. And if the z-score is positive 2, which means that the value is 2 standard deviation above the mean. And also we can think about the proportion of cases. So between z-score -2 to 0 in this area, there are 47.5% of cases. Now this is symmetrical. So between 0 and the 2, there are also 47.5% of cases. So in conclusion, in the total yellow area, between z-score -2 to +2, in the yellow area, approximately 95% of cases fall here. So approximately 95% of cases fall within 2 standard deviation of the mean. So to summarize, if the z-score is 0, half of the people are below the mean or above the mean, below the z-score of 0 or above the z-score of 0. And also, approximately 68% of cases fall within 1 standard deviation of the mean, between z-score -1 to +1. And also, within 2 standard deviation of the mean, between z-score -2 to +2, there are approximately 95% of cases fall within those values. Next, we'll go to the probability part. So in the probability part, you have to think about the meaning of the terminology and how these terminologies apply to some real situations. So you have to review some terminologies like long-run relative frequency, optimism bias, independence, mutual exclusiveness, base rate fallacy, availability heuristics. And also you have to calculate the expected values. So for the expected value, you can go to the lecture slide. And it's really easy to calculate. You can just practice 1 or 2 times and that's it. And also you can think about the ways to improve assessment of risk and probabilities. So in this video, I will review some kinds of terminologies related to probability. First, the long-run relative frequency reflects the proportion of events occurring in a large number of trials. So to get a kind of accurate probability, a large number of trials should be conducted many times. So this should be a large numbers. So which is different from a small number of trials, personal judgment, and judgment based on expert opinions. So the long-run relative frequency, you can think about a large number of trials to get accurate result of probability. And for the optimism bias is one's tendency to overestimate the likelihood of positive event, but underestimate the likelihood of negative events. And also the independence is that one event occur does not change the probability of the other event, which means that one event cannot determine or decide the probability of other event. That's the independence. So what is the mutual exclusive? The mutual exclusive means that 2 events cannot occur at the same time. So they are exclusive with each other. So for example, if the recitation 1 starts at 3 p.m. Tuesday and recitation 2 is 3 p.m. Tuesday, then we cannot take both recitation at the same time because they are mutually exclusive. Two events cannot occur at the same time. Also, you can review some terminologies like base rate policy and availability heuristics. Next, we'll go to the distribution part. So when you study distribution, first you have to think about characteristics of standard normal distribution. Just for review, the characteristics of standard normal distribution is mean equals to 0, standard deviation equals 1, and distribution is symmetrical. So these are the characteristics, and you can review those things. And also you can think about skewness, whether the data are negatively skewed, normal, no skewed, or normal distribution, or positively skewed. So for the negatively skewed, the left tail is longer here, and most of the values are concentrated on the right of the figure. Like this is the negatively skewed data. For normal distribution, there's no skewness, or this is really symmetrical around the mean. However, for the positive skewness, the right tail here is longer, and most of the values are concentrated on the left of the figure. So most of the values are around the 0 or close to the 0. This is how the positively skewed look. So for the exam, you have to think about how the skewness looks like. And you can also think about some examples of negative skewness and the positive skewness. And now, in the next, I will talk about some regressions. So we usually in here is a talk about linear regression. And regression is basically about how the changes in one variable impact the changes in the other. So to find the relationship between two variables, or to find the relationship between x and y, researchers try to find the best fitting line to explain the relationship between independent x and the dependent variable y. And also the linear regression can be graphically depicted using a straight line with a slope defining how changes in one variable impacts the changes in the other. So let's think about this example. So the relationship between temperature and frequency of eating ice cream. Suppose, so the blue one is the dot, the data for each individuals, and the graph shows that as temperature increases, more people on average are more likely to eat ice cream at MSU Dairy Store. So maybe some people really like the ice cream, so even the weather is really cold, can eat ice cream. However, other people don't like the ice cream, so in the summer they don't eat ice cream. However, if you see the trend, overall trend, like this people, when you see this overall trend, you can find that as temperature increases, more people are likely to eat ice cream. So I try to draw the line that best represents the relationship between temperature and the ice cream. So one students draw the yellow-green line here. However, other students draw the red line. Which one is the best fitting line? Which one best represent the relationship between temperature and the ice cream? Maybe the answer is green one, because green one shows green one is the best fitting line. Green one shows that as weather increases, temperature increases, more likely to eat ice cream. So the green line is the best fitting line and best represent the relationship between temperature and buying ice cream at their score, which means that the green line has the small levels of arrow, small amount of arrows. However, if you think about, you can think of the red line here. The red line shows that there's no clear relationship between temperature and the buying ice cream at every store. So as weather increases, the frequency of eating ice cream does not change at all. So we can conclude that the red line is not a good line. The red line does not represent the relationship between temperature and eating ice cream. So this is not a best fitting line, which means that the red line has a large amount of error because it does not represent the relationship very well. So in conclusion, to summarize, the green one is the best fitting line, best represent the relationship between temperature and eating ice cream with small amount of error. However, the red line does not represent the relationship well. It's not a best fitting line and has large amount of errors. So in this way, when you review regression, you have to think about which line is the best fitting line, best represents the relationship, and how about the error in each lines in the relationship. And also in the regression, you can think about 2 points. First one is slope, another one is constant or intercept. For the slope shows that how changes in x influence changes in y. So the graph shows that how changes in temperature impacts changes in frequency of eating ice cream. So with the slope, the linear regression shows how changes in x influence the changes in y. So for example, we can say every time the temperature rises by 10 degrees, people on average are likely to buy 2 more ice creams. As 10 degree increases, 2 people are likely to eat 2 more ice creams. This is the way to interpret the slope. And at the same time, the regression, we can see the intercept or constant, which means that the value of y when the x is 0. The intercept of the linear regression represents the value of one variable, like eating ice cream, when the value of the other temperature is 0. Like if the temperature is 0, on average, how many people buy ice creams at the MSU Dairy store? That's what the intercept means. So in the exam, you can calculate the slope and the constant using the formula. The formula is not that complicated, but you will provide it with some information, and by combining this information, numbers, you can calculate the slope and the constant. First, for the slope, which is called B, equals to R times Sy divided by Sx, which means that R means correlation, Sy is standard deviation of y, Sx is standard deviation of x. So correlation times standard deviation of y divided by the standard deviation of x. Also for the constant, formula is y bar minus bx bar. So we already calculated the b here, it's the slope, and y bar is mean of y, and x bar is mean of x. So the constant is mean of y minus slope you calculated times mean of x. Then you can get a constant. So in this way, by putting numbers in the formula, you can get slope and the constant. Okay, this is the last one. So is the level sum measurement. So we talk about level sum measurement. We already covered in exam 1, but in the exam 2, we also include some levels of measurement questions. So again, because this is really important. So I just want to review very fastly for each level of measurement. The first one is nominal measure. which means that there's no order among attributes. Like where I come from, Wisconsin, Michigan, Ohio. There's no order in each state, like Michigan, Ohio, Wisconsin. Or which party are you support? I'm Democrat, Independent, Republican. There's no natural order among these attributes. Then we can say this is the nominal variable, the nominal levels. Ordinal one is that there are logically ranked attributes or logically ranked orders between attributes, like strongly agree, or strongly disagree. So strongly agree means high levels of agreement, then somewhat agree or disagree. So these are the example of nominal measure. And the third one is interval measure. The characteristics of the interval measure is that the values are logically ranked each other, distance among attributes has no meaning, and there's no meaningful zero. You can think about the temperature. We'll talk about this example in the recitation. What is the 0 degrees of temperature? Is that does not feel cold or does not feel warm? The 0 degrees of temperature, like Fahrenheit, Celsius, are arbitrarily decided by the scientists. So let's decide that this levels of cold or warmth is 0. So in the interval measure, there is no meaningful 0 here, like temperature. However, in the ratio measure, the attributes are logically ranked, ordered, and distance among attributes has a meaning. Another big characteristic is that in the ratio measure, the 0 has a meaning. 0 means nothing. I have 0 money, which means that I don't have any money. I will take 0 communication courses this semester, which means that I will not take any courses in the communication department. So the ratio measure, so 0 has a true meaning or meaningful 0, or the 0 means nothing. So in this way, you can review these 4 levels of measurement to prepare the exam 2. So this is all about exam 2 review video. So good luck with the exam. And don't forget to bring pencils and student ID card. And most important one, a calculator. And the phone calculator is not allowed. So good luck with the exam. And if you have any questions, please feel free to send me an email and come to my office. Bye-bye. See you.